class I have told you about some preliminary idea about the what is an atom. Okay. Now regarding to that, there was one concept, that is what is Dalton's atomic theory. It is regarding to that theory which introduces us about the atom. Okay. And there was some examples, that is the bricks when we constructing a building, and when the cells, one cell of a whole organism, these are called as an atom. And from the Dalton's point of view, the atom is non-destructible and it cannot be created nor can be destroyed in a chemical reaction. And when atoms react to form the compounds, now from here, from this postulates, we can told that the atoms combine to form the compounds. Okay. Now the next portion, that is after the atom, it is the molecules will come. Okay, because the chapters contains two words, atoms and molecules. So the atom is the tiny particle which is in between all the materials. Now there you can see in page number 33, there are some symbols is there, and Dalton first used such kind of signs so that the elements can be detected easily. Okay. But at that time, at 1893, there was a few elements was there. As a few elements was there, and it was easier to represent it by using some symbols like that, a point inside a circle, one plus sign inside a circle. Okay. Okay. Next one, that is having a C inside a circle. These are the symbols. One L inside the circle, one G inside the circle. These are the representation of the atoms, and atoms of different elements. So these are the representation of different elements. Okay. Now this is called the symbol to represent the elements. Clear? In page number 33, you can see also in figure 3.2 an image of the surface of silicon. An image, sir, in that last one there will be some lines also. Not it is the gold, yes, here is the, for gold there is the line like that. As it is very valuable was there, so it is represented by special kind. For mercury you can see some same kind of sign is there. Okay, but there is no M. Now these names are collected from the, some are collected from the Latin word, and sometimes it is that's just from the first word. For example, I am coming with one example, that is magnesium. Okay, now it is the spelling of that word. Now here the first letter and the third letter is taken as a symbol. So M small g will be the symbol. So in that way, first word and the second word, first word and the third word is taken as an example. If there is a similarity is found in between two, then suppose manganese, magnesium and manganese, MANGANEAC. Now you can see that the first two words having the same words. First two words are same. So again here first word and the third word is taken to represent the elements. So by this way, it will be easier to represent the elements by symbol. So what is symbol? Symbol is the unique representation of an element, and it is given by IUPAC. I have told you earlier that IUPAC is the recommendation authority which authorizes the symbol and also the name of different organic, inorganic compounds. So this is the symbol. Next one is that the concept of molecules. Now before going to the concept of molecules, there are some binding forces. Binding forces. What are the binding forces? Okay. Now just think about one metal rod. Just think about one metal rod. Okay. Now if it is a metal and it is of a wood, now in which one the less force will be required to break into two parts? Here obviously, because in metal it's having high tensile strength. As our objectives is to bisect the wood particles or the wood stick, and here is the metal wires. Now here due to the more tensile strength, here high force is required to break down into two pieces, but it is less than the wood. Now from that it is told that there is some binding forces. The particles are binding in between themselves. And what kind of force is there? In chemical term, there are two kinds of force. There is one is due to the electron sharing, or covalent. Another one is that electrovalent or by electron releasing or accepting. So electron sharing, and next one by accepting electrons or releasing electrons. Now electron sharing forms the covalent compounds, and releasing it forms electrovalent compounds. Okay, so the name of the compounds is the covalent compound and electrovalent compound, and in behind this that type of bonds there is electron sharing, and here releasing of electron or accepting of electron. Now which one species will accept electron or which one will liberate electron, it will depends on the characteristics of that element. It will be discussed later on. Okay, so this is the binding forces. Now with respect to that binding forces, the molecules are formed, because two nitrogen atom or two oxygen atom when are connected by some binding forces, then they forms the molecule. Okay, so when atoms combined by some binding forces, or the another name is called the chemical forces, then it is the molecule is formed. Now on the last day there was a context was there, that is what is the difference between the elements, that is is there any difference in between nitrogen or CaO? Both are the molecules of a compound. Here it is the nitrogen gas, here it is calcium oxide, but both are molecules. Here heteroatom is there, here the homonuclear atom is there. Okay. So when molecules is formed, there are some binding forces in between these. Okay. Okay, now follow the page number 35. A molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence and show all of its properties of that substances. Okay. Now, what are the characteristics? It is defined as the smallest particle of an element. It is the smallest particle of an element. Suppose if it is of slackline. If it is of slackline, it is having the formula of calcium hydroxide. Now, if we dissociate the particles of the slackline, then at last what the substance will be left, and it is that of the part or the tiny part of the slackline or calcium hydroxide. We cannot dissociate calcium or hydroxide because of there are some binding forces, the chemical forces is there which cannot be breakable easily. Okay. So this is the one characteristics of molecule. Another one is that independent existence. Now, when it is the tiny particle of any slackline or magnesium chloride or any salt or any nitrogen gases, suppose it is out of the nitrogen gas. Now, when there is a single molecule is there, it represents its property. It will be proved by its property, because we have know it from the Daltons that the atoms combined to form the molecules, and here the property of the molecule and atoms are different. Okay. So, as the gas property, that is nitrogen, the single molecule having the same property of that substances. So, the single molecule can retain its existence by its property. And there is the another definition is given: atoms of same element or of different element can join together to form molecules. There is the example calcium oxide. Here the calcium and oxygen is there, and here two nitrogen atom. The binding force I have discussed earlier, it is maybe of electrovalent or it may be covalent. Okay. It will be discussed on the special topic, that is the electrovalency or covalency part. Now, here as there are some binding forces, they are attached with one another and we cannot break it easily. So, we can define molecules in the different ways, that is when the atoms of same or different element combine together with some chemical binding forces, then it is called the molecules, and it is the tiny particle of the substance which retains all the properties of that substance and can be exist independently is called also the molecule. Understood? Next portion is that we have to know about some of the molecules. Now, can you tell me what is the difference between O3 and O2? Anyone? What is the difference between? What is the chemical name of electrolyte? Electrolyte, it may be acid or it may be base, or it may be also salt. Mass difference, yes, it also may be the reason. Now, one difference, the preliminary difference is that both these two are formed by oxygen atom. Oxygen atom. Now, the atomicity is different. Here the atomicity is 3, here atomicity is 2, correct? As atomicity is different, so there obviously be the um, there obviously be a difference in the mass. So the Amrita has given the mass difference. Obviously there should be the difference. One more oxygen, Ronit, it is also correct. So it is the difference due to the O2 is oxygen, multiple proportion. Yes, it is also correct. Here according to the mass it is of 48 and it is of 32. So it is, if we simplify it, then it would be 4, that is of 3 is to 2. So it is the simple difference, that is the proportion, multiple proportion is observed here, which we get from Dalton's atomic theory. Okay, it is a monovalent electropositive. Which one monovalent electropositive? O3. O2 is neutral. O3, it's having different polar structures according to the electronic distribution on the head of the oxygen atom. Okay, because on the later stage you will know about the resonating structures, that is ozone represented as 2 resonating structures, and there you will get the polarity. Okay, next. So what is atomicity? The number of atoms constituting a molecule is known as atomicity. Now it is not that every time there should be multiple atoms. It is not correct every time that there should be multiple atoms to form the compound. Suppose carbon. Okay, so carbon is an element and also represent as a the molecule also. Okay, so carbon molecule is C, so it is a homomolecular, that is unimolecular. Here the atomicity is 1. And also the metals, that is platinum, the copper, these are all time they are monoatomic in nature. Cu, here 1, platinum 1, carbon here the 1, but hydrogen, the oxygen, the ozone, nitrogen, these are different atomicities there, 2, 2, 3, 2, etc. So it is the difference between homonuclear and heteronuclear, or unimolecular and bimolecular or polymolecular molecules. Next one. Now there is the examples given. Follow table 3.3, atomicity of some elements. Argon, it is monoatomic. Now when in the later stage you will come to know about the argon, it is an inert gas. Okay, so it exists in the periodic table group 18. So all the group 18 elements are monoatomic in nature. All the group 18 elements are monoatomic. What are the members of group 18? Helium, neon, argon, krypton, xenon and radon. These are the elements of group 18, and these are all monoatomic in nature. Later one, helium, it is also monoatomic, it is also of inert gas. Next one, oxygen, you know about it, diatomic. Okay. Coming to the next topic, that is hydrogen diatomic, nitrogen also diatomic, chlorine also diatomic, phosphorus also tetraatomic, and sulfur is polyatomic. Now what about phosphorus? It is a P4, and what about sulfur? It is S8. Okay, so these are the different atomicity of the elements. Next one is molecule. I have already discussed. What about molecules? Now follow table 3.4. That is the water having hydrogen and oxygen, and the mass ratio is equal to 1:8. In ammonia, it is nitrogen and hydrogen. The mass ratio is 14:3. How 14:3 is observed here? H2O. Here mass of hydrogen is 1, mass of oxygen, 1 into 2, mass of oxygen, that is of 16, so 2:16, that is simplifying it 1:8. NH3, it is the formula of ammonia, nitrogen having atomic mass of 14, hydrogen again 3, so NH2 8, H equal to 14:3. So these are the mass ratio. Another one example, carbon dioxide. Carbon dioxide have the formula CO2, carbon having mass of 12, oxygen that is of 32, so C is to O, that is equal to 12 is to 32. Two is to 6, 16, 3:8. So it would be 3:8. So here from that compound you can also tell that the postulates of Dalton's are correct. Here simple ratio, mass ratio, simple mass ratio, here also simple mass ratio is obtained. Okay. So these are the different examples. Now coming to the next part, there is an activity given. Now the activity tells about the element, ratio by mass, atomic mass, and mass ratio, and the simplest ratio, that is 2:1 in case of water. Now what is an ion? What is an ion? Now just think about the two nitrogen atoms are linked together by winding forces, and some complex compound, the structure is just for a compound, calcium oxide. Just think about calcium oxide. Okay. Now the calcium oxide, when the dissociation of nitrogen will obviously make nitrogen atom, because there is no electronegativity or the charge or the property of the element is same. But if the property of the element is different, that is here you can see the calcium's property and the oxygen's property are different. Here you can see if it dissociates, it will form two ions, that is two parts. One part is ammonia and another part ammonium, another part is chlorine. Now when this bond, that is CaO bond, it breaks, then there is a tendency to separation of charge, because all the binding forces are basically due to the electrostatic interaction. All the binding forces are due to some electrostatic interaction. Now here when the bond breaks, then there is the separation of charge arises. So as the separation of charge is there, then there two poles are generated. So separation of charge, then two poles are generated, and this part, the poles, that is the newly formed substance, can exist individually. Okay. Now the newly formed substance exists individually and also it works in the chemical reaction. So as the separation of charge, that is when the bond breaks, there is the separation of charge in between the subpart and creates a pole, and this pole, we know the poles are of two types, one is positive pole, another one is negative pole. So when such kind of poles is generated, when a molecule dissociates, then the subpart is called as ion, and it's having two types, one is positive charge, another one is negative charge. Okay. So this is the different positive and negative ion, and the subpart is called as ion. Now follow the definition is maybe given here. The charge species are known as ion. Now I have told you in detail how the charge is produced when there is a chemical interaction is there, and when some forces produces to the molecules to break down the interactive forces, then the charge is separated and the ions are produced. Okay. Okay. So any confusion up to that? Only up to the definition of ion is done today. Next day I will tell about the details of the different ions. That is how the ions are represented.